Hi guys, and welcome to Activity 10 of the Year 8 Physical Science course. In this unit we're going to be looking at energy efficiency. Okay, now energy efficiency is basically a rating which is given to any machine which is going to convert energy from one form into another. Let's look at this car here. We've got a Ferrari sitting here looking really nice, but basically it's got one function. Now, we all know that we have to put fuel into a car, so there's the starting energy. We've got chemical energy going into the car. What we want from the car is for it to go from A to B. Forget about all the bells and whistles and all the radio and the heating or the aircon or what have you. All we want that car to do is to move from A to B. That's our desired energy. So we are going to transform, or the car is going to transform, chemical energy on one side to kinetic energy on the other side. Okay, now unfortunately, this car is not 100% efficient because it gives off other energies. Now the other energies come in the form of heat and sound. So we can build up an energy flow diagram similar to the one below. We start off with our chemical energy. It can produce our desired effect, kinetic energy, but we are also going to get heat energy and sound energy. Now, if you remember back to earlier, the law of conservation of energy states that the energy coming in must equal the energy coming out. So the heat energy plus the kinetic energy plus the sound energy must equal the same amount of energy as is present in the chemical energy. Now the question is, how much of the chemical energy is converted into kinetic energy, our desired energy? The better the machine is, the more efficient the machine is, the more energy is going to be produced from our source energy. So, to recap, a machine is basically a tool that is going to convert or transform one type of energy into another. The better the efficiency, the more that energy is transformed to our desired type. What's left over, the difference between the desired energy and the source energy, is going to be our wasted energy. Now, the more efficient the machine is, the more desired energy will come about. The question is, how do we calculate the efficiency? Well, we use the equation that we've got below that basically states energy efficiency equals the output energy divided by the input energy multiplied by 100. And this is always written as a percentage. So you will have a percentage efficiency rating on a machine saying how good it is as it moves through from one type to another. Now you'll see this a lot on certain fridges, dishwashers, washing machines. You'll see a star system, and they'll say how efficient it is at converting electrical energy into its desired energy that the machine is going to perform. The higher up this number of stars, the more efficient it is, the better it is at converting one type of energy into another. Okay, so to help us with our calculations, I've put together some examples here for us to work through. So the first one is just going to be working out what is the efficiency of a machine converting 435 joules of energy from 750 joules. Now the first thing to do is to write down what you know. Well, we know the input energy, 750 joules, the output energy, 435 joules, and we're going to calculate the efficiency. We're going to use the formula, efficiency equals output energy divided by input energy multiplied by 100. So I substitute in for the words. Instead of output energy, I'm going to have 435, and instead of input energy, I'm going to have 750. So on my calculator, I'm going to do 435 divided by 750 times 100, and I come out with an answer of 58%. That means that the machine converts virtually just over half the amount of input energy into our desired energy. It's not very efficient. That means that we've got a further 42% of that input energy which is wasted. Okay, it's gone off in other forms, heat, sound, light, depending on what the machine is. So it's not a very good, efficient machine. Okay, so let's look at another one. In this case, we've got a refrigerator which is 69% efficient. So we've been given its efficiency rating. It's an input energy of 1300 joules, and we are asked to calculate the output energy. So first things first, write down what you know. Input energy, 1300 joules. Efficiency, 69%, but we don't know our output. Use our formula, output energy divided by input energy times 100, and substitute in what we know. Well, we're going to substitute in for efficiency, which is 69, and input energy, which is 1300. We're going to use a question mark for our output energy. So the first thing I want to do is to put all of the numbers on the left-hand side, leaving me with the question mark on the right-hand side. So let's start off with the 100. Now that 100 there is multiplying the question mark. So I want to take it to the other side of the equal sign. So if it's multiplying on one side and I want to take it to the other side, I need to divide by 100. So I get 69 divided by 100 equals question mark, or the output energy, over 1300. Now I want to move the 1300 over onto the left-hand side. It's dividing on the right-hand side, so it's got to do the opposite function if I move it to the left-hand side, so I've got to multiply by 1300. So I get the function 69 divided by 100 times 1300 will give me my output energy. Put that into your calculator, and we end up with an output energy of 897 joules. Okay, the final example we've got is looking at calculating the input energy. We're given the efficiency, we're given the output energy, so we write down what we know, we're finding the input energy, our output energy is 347 joules, our efficiency is 72%. Okay, so we're going to be using our efficiency equation, substitute in for what we know. We know we've got an efficiency of 72, an output of 347, and we've got 100, and we multiply it by 100. So what we want to do is to move the question mark over to the left-hand side. So I'm going to multiply the left-hand side by the question mark, because I don't want the question mark at the bottom, I want to move it up so it's all on one row. So now I say to myself, right, what do I got to do to keep the question mark on its own? We're going to get rid of that 72. So the 72 is multiplying the question mark on the left-hand side. So to move it to the other side, do the opposite function. So I've got to divide by 72, which means that we get the output energy is 347 divided by 72 times 100, which gives me an overall input energy of 482 joules. Okay, so I hope that makes sense. You've now got 3 examples as to how to deal with energy efficiency. What I'd like you to do, or a good opportunity, is to go through and have a go at the exercises which is in this post. By the way, I've just noticed that there's a typo here. Instead of output energy, it should actually read input energy, so I apologize for that. But if you use these 3 videos, or these 3 examples, you'll be able to answer anything on activity 10. Now, for our year 8s, don't worry that the equation is going to be given to you in the test. So it's not going to be something that you have to go away and learn. You'll be given the equation, you just need to be able to use it. Okay, so I hope that makes sense with respect to working out the efficiency rating for a machine, and hopefully you'll now got all the skills necessary to be able to go away and solve any calculation to do with efficiency. Thank you for watching, and I look forward to seeing you again.